Okay, 2, 3, 6, 3. All right, what's next? What kind of a line segment is this? Yeah, be a little more descriptive, shall we?
It's a closed linear line.
What kind of a line is it?
A straight line, a line.
What kind of a line is it? Horizontal, thank you. What is true of the coordinates of points on the same horizontal line? Same y values. Or same y coordinates. What is the distance between these 2 points? 4 units. How could you determine this distance just by using the coordinates of the points? Well, you got coordinates. How are you going to get a 4 out of those? Subtract the x coordinates. Use your rule to determine the distance between -4, 5 and 2, 5. Remembering that distance is always a positive number. So what are we going to show?
Two, 5 minus 2 minus 4. 6.
Okay, so we're going to go 2 minus -4, right? If we subtract the smaller from the larger, then we should end up with a positive number, yeah? Verify your answer by plotting the points on the above grid and determining the distance from the graph. Okay, so what were the points? 4, -4, 5, 2, 5. 1, 2, 3, 4, 5, 6. Yes. Okay, so check. 2 points on the same horizontal line are x2, y and x1, y. Write an expression for the distance between x2, y and x1, y.
X2, y minus x1, x2 minus x1.
Okay, so what do we need to do? Just subtract the x coordinates, right? So x2 minus x1 will be the distance between 2 horizontal points. Questions on this page? Plot the points -3, 1 and -3, 6. -3, 1, -3, 6. And connect them with a line segment. Label the points. Okay. What kind of line segment is this?
Vertical.
Vertical, right? See, the answers get easier now that after we figured out the last one was horizontal. What is true of the coordinates of points on the same vertical line?
Same x value.
Okay, so the same x coordinates. Right? This should just go blazingly fast now. What is the distance between these 2 points? 5. How could you determine the distance by using the coordinates of the points?
Subtract
Subtract the y coordinates. Use your rule to determine the distance between 5, -2 and 5, 5. Remember that distance is always a positive number. So what are we going to do?
5 minus -2.
Verify your answer by plotting the points on the above grid and determining the distance from the graph. 5, -2, and 5, 5. 5, -2. 1, 2, 3, 4, 5, 6, 7. Two points on the same vertical line are x comma y2 and x comma y1. Write an expression for the distance between x, y2 and x, y1. Anyone?
y2 minus y1.
Y2 minus y1. Questions? Okay, next page. Plot the points 2, 3, and 5, 7 and connect them with a straight line. Label the points. 2, 3, 5, 7. Okay, so I'll give you a moment. Is that on? What kind of line segment is this?
Diagonal.
What's the fancy name for it? Oblique. No, diagonal refers to a line joining 2 points in a figure. You're drawing a diagonal, not really a diagonal. It's an oblique line. It's on an angle. What is the distance between these 2 points? Hint, draw a right triangle with the segment as the hypotenuse. 1, 2, 3, 1, 2, 3, 4. So what's the distance?
5.
Okay, so we made a right triangle. It had legs of 3 and 4. We wanted to get the hypotenuse. Call that d. D squared is 3 squared plus 4 squared. 25. Why don't I write d as plus or minus 5?
Because you can have a minus 5.
Because it's a distance, and what do we know about distances? They're always positive. How could you use the coordinates of the points to determine the length of the horizontal line segment? Okay, the horizontal segment. How do we get the horizontal segment?
Minus the x value.
Yeah, well, we use the word subtract. Subtract the x coordinates. Because they're the only thing that differs on the horizontal line. How could you use the coordinates of the points to determine the length of the vertical line segment? Subtract the y coordinates. Use your rule to determine the distance between 5, -1 and 7, 6. Remember that distance is always a positive number. Okay, so what do we have to work out first? That first thing we need is the horizontal distance, which is what?
7 minus minus
Okay, so the horizontal distance is 7 minus 5, which is 12. What's the vertical distance?
6 minus 1.
Which is 5. And so how do I calculate the distance?
12 to the power of 2 plus 5 to the power of 2, which is 144 plus 25.
Okay, so we take the sum of the squares of the horizontal and vertical distances, and then we'll square root that. And that gives us the distance between the 2 points. So for the points P2, which are x2, y2, and P1, which is x1, y1, write an expression for the length of the horizontal line segment. So what's going to be?
X2 minus x1.
Write an expression for the length of the vertical line segment.
Y2 minus y1.
Write an equation to determine the distance between the 2 points.
X2 minus x1 to the power of 2 plus, root of x2, yeah, minus x1 plus, yeah.
So let's start with that, and now we'll do your idea, right, which is to take the root. Now, one nice thing about this formula is, since we're squaring the numbers, it really doesn't matter what order we do the subtraction, right? Whether we do the higher minus the lower or the lower minus the higher, right? It doesn't matter if you get positive 5 for the distance or negative 5 for the horizontal distance, because we'll be squaring it. So that will take care of any negative signs, right? Okay, this is called the distance formula. Yeah, I expect IB will give it to you because they give you everything else. Yeah. Determine the distance between the 2 points shown on the grid to the right. All right, what's the secret to math again? Formula, substitution, and answer. Okay, so we could just do this by counting, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So we could go d squared is equal to 6 squared plus 8 squared. D squared is 100. And d is equal to 10. Right? But it's nicer to have the formula, right? Because, I mean, this only works if you got it, you plot it, and you count it. Right? So you can count it out on the grid. If you don't want to count it, if you're just given the points, and you use the distance formula. Now, if that's the case, then we need to choose one of these points to be point 1 and one of these points to be point 2. Any particular, what do you want this one to be? Point 1 or point 2? Okay, so point 1 is negative 3, 5. And that makes point 2 what? 5 and negative 1. Once you name the points, then they stay. Okay, so you're going to go 5 minus negative 3, so it's the square root of 5 minus negative 3 squared plus negative 1 minus 5 squared. Okay, so I may have gone into way too much detail there, but. So put the formula down, substitute in your points, okay, keeping straight. Once you've named this point 2, then x2 becomes 5, and y2 is negative 1. Bless you. Okay, so you don't get to go switching things around and just say, well, I could take them in any order, right? It doesn't matter. Which for this, it doesn't matter, but for the rest of coordinate geometry, it will matter. So once we've labeled a point, point 1, that becomes x1, y1, and the other point, point 2, becomes x2, y2. Okay, let's move on. Example 2. The vertices of a triangle are A, 3, negative 2, B, negative 5, negative 4, and C, 1, negative 6. Is the triangle scalene, isosceles, or equilateral? Provide evidence to support your answer. Okay, so how are we going to figure out what kind of triangle it is? Draw it. Yeah, I could draw it, but what good will that do? Are any of those lines horizontal or vertical? No. What do I need to know to determine what kind of triangle it is? Isosceles, two sides are the same. So what do I have to find out? Distances between each point, right? I need to figure out how long AB is, how long BC is, and how long AC is. Once I know that, if they're all the same, I'll say it's equilateral. If 2 out of 3 are the same, I'll say it's isosceles, and if all 3 are different, then I will say that it is scalene. So we want to work out the distance from A to B. So keeping in mind just general distance formula. And substituting in, so AB, which one's going to be x2? 3 or negative 5? 3. Doesn't matter. But once I've chosen 3 to be x2, then that chooses negative 2 to be y2. Okay, so let's just work this out going across so we have some room. So 3 minus negative 5 is 8, so we get 8 squared. Negative 2 minus negative 4 is? So that's the square root of 64 plus the square root of 4, or sorry, square root of 64 plus 4, which is root 68. And what does that reduce to? Okay, the largest perfect square that goes into 68 is 4. And that means that's 2 root 17. Okay, you got 2 more to work out, so go ahead, you work them out. You need the distance from B to C. All right, so what do I know now? What isn't it of the 3, scalene, isosceles, or equilateral? not equilateral. So what kind of triangle? Want to say something?
Oh, yeah.
Somebody should want to say something. No? 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 Okay. Is there anything wrong that's written up there?
The minus portion.
Should they be? So I didn't actually figure out the distance from A to C, did I? I just redid the calculation of A to B. Yeah, come on, you guys gotta pay attention. Well, pay attention. You guys just sit there and write down everything that's written in front of you. Just tear it this.
I did that there, okay.
Okay, what kind of triangle is it? Okay, scalene. Since all three sides are different lengths. But wait, there's more. Determine the perimeter of the triangle. Express your answer as an exact value and round it to the nearest hundredth. So what do we have to do to get the perimeter of the triangle? So how does that simplify? Got 2 root 17s and 2 root 10s and 2 root 5s. So what does that up to? You can't simplify, right? There's no like radicals. But we don't want to value rounded to the nearest hundredth, so you can work it out. What does it work out to? Calculators out, punching away. AC is Anthony Calvillo, quarterback for the Montreal.
Yes, I like that answer better.
Nearest hundredth.
That's a 4.
Okay, 19.04. If I ask the nearest hundredth, don't go reading off decimals beyond 2, right? Round it. Is the triangle a right triangle? Provide evidence to support your answer. What would make it a right triangle? If a squared plus b squared equals c squared. So in this case, what's the biggest of all of these radicals?
2 root
2 root 17. But you know what? I'm going to call it root 68. It's the root of 68 squared equal to, what were the other 2 roots that I had? 40 and 20. See, it's easier to be in this form than it is to be 2 root 17, right? That doesn't really help me. So is 68 equal to 40 plus 20?
Yes.
No.
I like mine.
So what are we going to say? The triangle is not a right triangle. So numbers that make a right triangle are called a Pythagorean triple, right? Like 3, 4, 5. 3 squared plus 4 squared equals 5 squared. Or 5, 12, 13. 5 squared plus 12 squared is 13 squared. So those are Pythagorean triples. This is not a Pythagorean triple. So it is not a right triangle. The diameter of a circle has endpoints -6, 3, and 10, -5. Determine the exact value of the radius. Okay, so what do we have to do here? What's the plan? What's the plan?
Find out the diameter, divide by 2.
How do I find the diameter? So what are we finding?
The distance.
Find the distance between the 2 points, which is the diameter. And then
Divide by 2.
divide by 2 to get the
Radius.
right. Brilliant. Okay? Okay, so the radius is 2 root 5 units, whatever a unit is in this case, right? We don't have any measurements given to us, so. Okay, questions? No? All good? Exercises. Well, that's for you to do, right?
Yeah.
Okay, so you've got some exercises. You have textbook work, and you have a test tomorrow. Okay, or a quiz, I guess.